So we'll see a few more examples on nomenclature of haloalkanes and haloarenes. Commonly, dihaloalkanes or alkyl dihalides are also called as alkaline halides or alkylidene halides. They can also be called as alkaline halides or commonly alkylidene halides. For example, common name ethylidene chloride. Ethylidene chloride. There is also one more compound called ethylene chloride. See, it is similar to this one, alkaline halide, alkylidene halide. Like that, we are writing here ethylidene like alkylidene and ethylene like alkaline. Now, what is the difference between this ethylidene chloride and ethylene chloride? By the name, we are not representing it as a dichloride, but commonly dihaloalkanes can be called as alkaline halides, alkylidene halides, like that, ethylidene chloride, ethylene chloride. So what is the difference, or when do you use ethylidene and when do you use ethylene chloride? Both are dihalo compounds only, dichlorides only. But what is the difference here? It is ethylene chloride is an example of vicinal dihalide or dichloride, you can say, and ethylidene chloride is an example of gem dihalide. So in that case, what will be the IUPAC nomenclature of ethylidene chloride and ethylene chloride? Is ethylidene chloride means, now I am writing here CH3, CH, Cl and Cl. As I said you, it is ethylidene is used for gem. So that means both the halogen atoms are present on same carbon. Both the chlorine atoms are present on same carbon. So according to IUPAC, you should start number on this carbon, right? This is number 1 carbon, this is number 2 carbon. So what will be the IUPAC nomenclature of ethylidene chloride? Is 1,1 dichloroethane. 1,1 dichloroethane is the IUPAC name of ethylidene chloride. Similarly, what is ethylene chloride? It is a vicinal dihalide. So that means I will write the two halogen atoms on adjacent carbons. So now number 1 and 2 can be written either from anyway, because both chlorine atoms are present adjacent to each other. So 1 and 2 I am writing like this. Now what will be the IUPAC nomenclature of ethylene chloride? IUPAC nomenclature will be 1,2 dichloroethane. 1,2 dichloroethane. You should never get confused by this common terms. Here ene is there, so it may be double bond, but that is wrong notation. Here ene is there, that may consist of double bond, but that is wrong notation. So you should remember dihalides, alkyl dihalides, or as I said you, dihaloalkanes commonly can be called as, means you can say it is common name for them. common name for them can be alkaline halides or alkylidine halides. In some books, they also give this name as alkaline dihalides directly and alkylidine dihalides directly. In that, we are taking two examples. Ethylidine chloride. Some books also can give it as ethylidine dichloride. There is nothing wrong. Common name can be written in any way. So, ethylidine chloride is an example of gem dihalide. This is the structure of the compound, and IUPAC name is 1,1-dichloroethane. And ethylene chloride is an example of vicinal dihalide. So I have written two chlorines adjacent to each other, and the IUPAC name will be 1,2-dichloroethane. So you should never confuse with this common name. Here it is containing ene, so you may think that it may consist of double bond, but that will be wrong. So commonly alkyl dihalides have this common name, alkaline halides or alkylidine halides. Okay, so we continue next example. Okay, now we will see a few more examples. Now what is the IUPAC name of bromobenzene? Like I am writing here, benzene ring. Okay, with one bromine atom. This is, what is the name commonly you can call, or the IUPAC name is bromobenzene. Bromobenzene. If there are two bromine atoms, they are adjacent to each other, then as you know, this can be called as ortho-dibromobenzene. Common name can be ortho-dibromobenzene. But what about IUPAC name of this compound? IUPAC name of this compound will be, here I can write 1 over here and 2 over here, or you can write 1 here or 2 here. There is nothing wrong. So what is the IUPAC name? 1,2 dibromobenzene. 1,2 dibromobenzene. Similarly, if you have bromine atoms attached in meta position, in para position, then you will say it as 1,3, 1,4. And what about the name of this type of tribromobenzene? Is the common name of this compound is symmetrical tribromobenzene. Common name of this compound is symmetrical tribromobenzene. But what about the IUPAC nomenclature for this compound? IUPAC. What is the IUPAC name of symmetrical tribromobenzene? So you start numbering from any side, it will, all the bromines falls under same numbers. For example, if I write like this, 1, 2, 3, 4, 5 and 6. Then see the numbers. At first carbon, one bromine atom. At third carbon, one more bromine atom. And at fifth carbon, one more bromine atom. So the IUPAC name of symmetrical tribromobenzene will be 1,3,5 tribromobenzene. 135 tribromobenzene. Few more examples. Methylene chloride. methylene chloride, chloroform, carbon tetrachloride. So what will be the IUPAC names of the given compounds? Okay, methylene chloride, as I said you, alkaline chloride or alkaline halide means it is dihalide. Okay, methyl chloride is different from methylene chloride. Methyl chloride is only containing one chlorine, but methylene, it is like alkaline halide. So alkaline halides basically contains two halogen atoms. So it is alkaline chloride. Alkaline chloride means methane with two chlorine atoms. Methyl chloride means methane group with means one hydrogen replaced with one chlorine atom. Chloroform, as you know, three chlorine atoms. Carbon tetrachlorides, four chlorine atoms. Let us see this one. The compound here is methyl chloride, so I am writing CH3Cl. That is the compound methyl chloride. Methylene chloride is CH2Cl2. Chloroform is CHCl3. Carbon tetrachloride is CCl4. Now what will the IUPAC names of these compounds? Now let us write the IUPAC name for first compound, that is methyl chloride. Methyl chloride is common name. So what will be the IUPAC name here? Chloromethane. IUPAC name of methyl chloride is chloromethane. IUPAC names. Okay. What will be the IUPAC name of methylene chloride? IUPAC name of methylene chloride is 1,1 dichloromethane. 1,1 dichloromethane. What will be the IUPAC name of chloroform? Okay, 1,1, okay, trichloromethane. Similarly, IUPAC name of carbon tetrachloride CCl4 is 1,1 tetrachloromethane. Now let us see the IUPAC name of the following two compounds. Now here in this compound we have got two functional groups, that is ene double bond and halo. Similarly here also ene and bromo. So halo groups and double bonds are there. So what will be the IUPAC name for this compound? The basic thing is, you know that compared to double bond and relative to bromine, when you compare these two functional groups, double bond should be given major priority. So that means if I start numbering from this side, this will become first carbon, it will be second, it will be third carbon if I do in this way. So it will come at position 3. But if I number from this carbon, this will be 1, this will be 2, 3, 4 and 5. If I number like this, double bond is falling under second position. So least number should be given to double bond, because ene is much priority according to IUPAC compared to bromine. halo group. So what should be the IUPAC name of this compound? This compound IUPAC name is 4-bromo. 4-bromo, because bromine is there, 4-bromo. And it is a 5-member chain. It is a 5-membered compound. So 4-bromo pent 2-ene is the IUPAC name of this compound. Similarly, here also we have to give much priority to the double bond only compared to the bromine atom. But if you look, if I number from this side, it will become 1, 2, 3, and this carbon is 4th carbon. Double bond is falling under second position. If I number from this side also, this is first carbon, this is second carbon, this is third, and this is fourth. So if I number from this side, this is first carbon, this is second carbon, this is third carbon, and fourth carbon. So either you number it from upside down or from down to upside. Double bond position is at second only. Double bond falls under second position only. But I will prefer it to number from this side. Why? Because if I number from this side, double bond is at second position and bromine is at fourth position. 2 plus 4 will give you bigger numbers, that is 6. But if I number from this side, it is 1, first position bromine, second position double bond. That means 1 plus 2, it will be 3. Here it is 2 plus 4, 6. Here it is 1 plus 2, it is 3. That means here if I number from this side, I will also follow which rule? Least sum rule. So which way of numbering is correct? From downside to upside, like this. So I will write numbers clearly. The numbers must be written like this. Here first carbon, this is second carbon, this is third carbon, and this is fourth carbon. So the name of this compound should be, first carbon is containing bromine, so 1-bromo, and it is a 4-membered compound, so bute. Okay, and where is double bond? Second position, so bute 2-ene. Now we will see the next topic, that is nature of CX bond. So alkyl halides or aryl halides means what? RX. What does R indicate? Alkyl group means carbon. So any carbon atom, it is attached with halogen atom. So what we can talk about nature of CX bond? As you know, carbon atom is less electronegative. It is less electronegative than halogen atoms. Right or not? You take any halogens in the periodic table, fluorine, chlorine, bromine, iodine, anything if you take, you know that halogens have higher electronegativities in the respective periods, right? So halogens electronegativity is higher than carbon. What does this mean? If you take any CX bond, due to higher electronegativity of the halogen atoms, always there will be partial negative charge on halogen atoms and partial positive charge on the carbon atom. That is, due to the electronegative difference between carbon and halogen atoms, there can arise partial polarity that is I am representing with a delta minus delta plus, partial positive and partial negative charge. Now what happens to the bond length and bond enthalpies from CF to CI? Means as you know, down the group size of the halogens increases. Size of the halogen increases. Down the group size of the halogen increases. If size of the halogen increases, what does that mean? Bond length increases. Bond length increases. And as you know that bond length and bond enthalpy are almost like inverse. Means longer the bond, easier it is to break. Shorter the bond, tougher it will be, or it requires more energy to break. That means from CF to CI, if I take bond lengths increases and bond enthalpy, bond enthalpies decreases. Bond enthalpies decreases.
Done, sir.
Now the next topic is preparation methods. Preparation methods of haloalkanes or haloarenes. Now in that, first we will see some preparation methods from alcohols. Some preparation methods we will see from alcohols. So in that we have again different reagents or the different methods you can obtain alkyl halides from alcohols. Now what is that? I am writing general formula of an alcohol, general representation, any compound, any alcohol, ROH I am writing. ROH plus HCl with anhydrous ZnCl2. Okay, that is alcohols on treating with HCl with anhydrous zinc chloride. You will get alkyl halides in this reaction. Okay, RCl you can get from this reaction. This particular process is also having a name called as Groovis process. That is synthesis of alkyl halides from alcohols with HCl and in the presence of anhydrous ZnCl2 is called Groovis process. Now in this or there is a drawback in this method, that is aromatic or you can say aryl halides. Aryl halides cannot be prepared, cannot be prepared by this method, Okay. Now why I am saying that aryl halides cannot be prepared by this method? Because if you take if you want aryl halide in this method, you have to take aromatic alcohol, aryl alcohol or aromatic alcohol you should take. That is the CO bond, the CO bond. In case of alkyl alcohols, it is easy to break, or it is containing single bond character. But in case of aryl alcohols, the CO bond acquires partial double bond character, or partial double bond in nature it is. So it is hard to break the partial double bond here between the carbon and oxygen in case of aryl alcohols. That is why we are saying in Lewis process you cannot prepare aryl halides, because in aryl alcohols the CO bond will have partial double bond character, whereas in alkyl alcohols it will have single bond character, which is easier to break. Okay. Now this is one drawback from Lewis process. And now if you compare among the alcohols in the sense tertiary alcohols would give you quick reaction or fast reaction with HCl anhydrous ZnCl2, and you will get a more amount of product, or you will get more predominant or more amount of products. In case of tertiary alcohols, the reaction is faster compared to secondary alcohols, then compared to primary alcohols, then compared to normal alkyl alcohols, or I can say methanol. You can take methanol. Okay, you can take methanol here. So tertiary alcohols readily react, or they give more amount of product compared to secondary alcohols, then compared to primary alcohols, then compared to methanol. This is the reactivity order in this Lewis process. And HCl with anhydrous ZnCl2 is also called as Lucas reagent. This topic again we will read in the next chapter of organic chemistry, that is alcohols, phenols and ethers.